Immune Mimicry explores why arteries can mistake harmless seasonal pollen for dangerous vascular threats. We bridge the molecular gap between a sneeze and a stroke by showing how the immune system identifies pollen proteins as invasive pathogens, triggering inflammation that quietly undermines long-term cardiovascular health. This evolutionary glitch causes inflammatory cytokines to breach arterial defenses. What begins as a seasonal allergy becomes a silent physiological assault, slowly compromising arterial integrity. Over time, repeated immune confusion transforms simple sniffles into a hidden cardiovascular risk. The immune system relies on protein pattern recognition to detect airborne threats during the intense spring bloom of 2026. Specialized receptors scan pollen proteins, searching for molecular signatures associated with danger, even when the threat is harmless. Certain proteins in ragweed and birch pollen share structural similarities with proteins found in the human arterial lining. These chemical resemblances confuse immune cells, making arterial tissue appear foreign during periods of height and allergic response. This failure to distinguish external allergens from internal tissue is known as immune mimicry. The body's defense system mistakenly targets itself, launching inflammatory responses intended for pollen but redirected toward blood vessels. A single sneeze signals the release of inflammatory cytokines. These chemical messengers do not stay confined to the nasal passages. Instead, they enter circulation, spreading immune activation throughout the body. As cytokines travel through the bloodstream, they encounter the vascular endothelium. Here, they act like a master key, unlocking protective barriers of the arteries and amplifying inflammation far from the original allergic trigger. This process leads to endothelial dysfunction. The normally smooth arterial lining becomes porous and sticky, losing its protective properties and creating a surface that encourages immune cell attachment. White blood cells, originally activated to fight pollen, begin adhering to vessel walls. Their presence inside the vascular system promotes localized inflammation and mechanical stress on delicate arterial tissue. Persistent inflammation causes microtears in the arterial wall. These tiny injuries accumulate over time, laying the groundwork for structural damage and long-term cardiovascular deterioration. Chronic seasonal allergy flares accelerate arterial plaque formation. The body attempts to repair perceived pollen-induced damage, but this healing response unintentionally traps cholesterol and cellular debris. A healthy artery remains flexible and clear. In contrast, years of repeated immune misidentification lead to thickened walls, plaque buildup, and permanent structural scarring that restricts blood flow. New 2026 immunotherapy breakthroughs aim to retrain the immune system, reducing exaggerated vascular responses during allergy seasons and preventing inflammatory spillover into the cardiovascular system. Monitoring systemic inflammation during peak allergy seasons is critical. Tracking biomarkers, managing allergies early, and reducing inflammatory load can help protect both immune balance and heart health. Understanding this molecular glitch is the first step in prevention. By recognizing how seasonal allergies can escalate into vascular damage, we can stop a simple sneeze from evolving into a cardiovascular crisis.
Next time you sneeze, ask yourself, is it just pollen, or is your heart paying the price in silence?